This example comes out of section 9.1. We're dealing with rational functions and transformations. Very open-ended instructions. Realistically on a test you'd be given a bit more than this, but I'm just asked to compare f of x equals 1 over x squared and this other function g of x equals 3 over x squared minus 12x plus 36. And then in question B, a very similar example, just with a different function to compare it to. If you graph y equals 1 over x squared, you get asymptotes at y, x equals 0 and y equals 0. And the curve is always positive because of that x squared term. And for example, it goes through the point 1, 1. It looks something like that. And you could get that straight off your graphing calculator, basically. Now that's your f, y equals f of x function right there. Now, y equals g of x. If we look at g of x a little bit closer, hopefully it looks to you even like a factoring problem from Math 10. The denominator here factors quite easily. It's just x minus 6 times x minus 6. So really we could look at the second function as a transformation of the first. We could say, well, if you took the first one and did a vertical stretch by a factor of 3 and then a horizontal translation of 6 units to the right, you would have the graph that we're talking about. So, if I stretch by a factor of 3, that doesn't change the asymptotes any, but if I move it 6 to the right, 1, 2, 3, 4, 5, 6, I now have an asymptote at x equals 6, and a non-permissible value, of course, at x equals 6, and the horizontal asymptote hasn't changed, it's at y equals 0. I have a curve that is kind of steeper than the one that I had drawn before. The point 1, 1, if we talk about what happens to that, it'll become 1, 3, and then it'll move 6 to the right, so it'll become 7, comma 3. So 7, comma 3 if I'm looking at my corresponding point. Another thing that you might be asked to compare more specifically are the domain and range. So the domain and range for f of x is just that x can't be 0, x element to the real numbers, and for the range, same idea, y can't be 0, y is element to the real numbers for the function above here. Now for this function we just drew, things have changed a little bit. The domain is different. X can't equal 6 now. Otherwise all real numbers are fine. And for y, up above here it wasn't y just can't equal 0, it's y is greater than 0. If you look at that graph, it's different than the ones we've been drawing before. There are no negative values on it. And this range is still the same. Y has to be greater than 0. Otherwise, all real numbers are fine. So, you can compare them in a number of ways. Maybe you compare the x-intercepts, the y-intercepts. But if we talk about g of x as a transformation of f of x, you've got a pretty good answer to the question. Now for the second one, I won't bother redrawing f of x equals 1 over x squared and just restating the domain and range. But if I look at the second one, basically it is again a transformation of the first. Probably most of you would prefer to write this as negative 1 over x plus 3 squared plus 2. So what we have here is reflection. If we reflect it in the x-axis, in other words, turn it upside down, we horizontally translate it 3 units to the left this time, and we do a vertical translation of 2 units up, we'll have the graph that we're looking for. So if I take the original and reflect it in the x-axis, I'm going to have something like this, upside down. Asymptotes stay the same, but my point is now 1, negative 1. If I do horizontal translation of 3 to the left, 1, 2, 3, my new vertical asymptote is x equals negative 3, still horizontal asymptote at y equals 0. The point that I was following has been moved 3 to the left, and so it's at negative 2, negative 1. And so the final graph here, if I take that graph and move it up, I still have a vertical asymptote at x equals negative 3. But my horizontal asymptote is now 2 units up, so it's at y equals 2. And we have the point that we've been following along, if I move it 2 units up, is going to be at negative 2, positive 1, somewhere about here. And we have our curve on either side of the asymptote there. Now, another thing that definitely we would want to say is something about the domain and the range. X, where x can't equal negative 3 in all real numbers, and the range y, where y is less than 2 in all real numbers would be some basis for comparison of this h of x function compared to the original 1 over x squared.